Okay, 6.4 is the fundamental theorem of algebra. So this is a huge result for this class. It's the fundamental theorem of algebra, okay? Here we want to learn about the fundamental theorem of algebra. We want to learn about multiple zeros and what they really mean. And we want to talk about conjugate pairs of zeros, okay? A summary of the polynomial methods will be on pages 418 and 419 of your books. But let's go through the actual fundamental theorem of algebra, and then I'll break it down. If P is a polynomial of degree n with n greater than or equal to 1, then P has at least one zero. That is, the equation P of x equals 0 has at least one solution. Note, the zero of P and consequently the solution of P of x equals 0 may be a non-real complex number, okay? The fundamental theorem of algebra tells you, in other words, that if you have a polynomial of degree n greater than or equal to 1, then it has to have one solution, at least one solution. That's what it says, okay? The linear factors theorem says given the polynomial P of x of degree n, where n is greater than or equal to 1, and the leading coefficient is non-zero, P can be factored as a sub n times x minus c1 times x minus c2 times everything out to x minus cn, where c sub 1, c sub 2 out to c sub n are constants, possibly non-real complex constants and not necessarily different. In other words, an nth degree polynomial can be factored as a product of n linear factors. What did we talk about in 6.3? What did we just talk about? The rational zeros theorem. And the way that I phrased the examples, whenever we went through and we factored it completely, we factored each polynomial as a polynomial of which we factored each polynomial completely as a product of what kind of factors? Linear factors. So is this new? No, we've already done it in 6.3. There's a reason why I set up the examples that way. Okay, what questions do you have? Okay, so this is just formally discussing what we've already talked about in 6.3, the way I phrased those examples. Okay, are we good? Okay, so some new information. Just whenever you're looking at a graph, a turning point of a graph is a point where the graph changes behavior from decreasing to increasing or from increasing to decreasing. Okay, a few facts. The graph of an nth degree polynomial function has at most n x-intercepts and at most n minus 1 turning points. This is important. Okay, this is important. The graph of an nth degree polynomial function has at most n x-intercepts and at most n minus 1 turning points. So it can have the degree minus 1 turning points. Okay, so for example, if you have a degree 3 polynomial, how many x-intercepts can it have at most?
2.
X-intercepts?
No, 3.
3, right? And how many turning points at most? 2. You got it. Okay? So it's another way of saying if you have an nth degree polynomial, your zeros tell you how many x-intercepts you can possibly have, you can have. And then your turning points, you'll have that degree minus 1 at most. Okay? So let's also note that an nth degree polynomial function has at most n zeros. That's the second fact. An nth degree polynomial function has at most n zeros. So, example 1. What kind of function is this? Even or odd? Or what type of degree will it have, even or odd? Will it be even or odd? And I'm asking you this because of the end behavior. Odd. Odd? The end behavior of odd functions look like what? Give me an example. I know. Okay, so I know you're used to using your arms. If you have x squared, what's the end behavior? Yeah, looks like, yeah, parabola up or down. Good. But if it's odd, like x cubed, what? Yeah, it looks like that. I see you doing it. It looks like that. That's odd degree. And then this is even degree or flipped, right? So just looking at this, this has what? Even degree, right? Right. So this is just a refresher of information we've covered, right? You don't need that for this specifically, because I tell you it's a fourth degree polynomial, okay? It has two x-intercepts, one here and one here, right? And then it has how many turning points where it goes from decreasing to increasing? How many? One right here, right? So it has one turning point. So again, this is the polynomial f of x equals x to the fourth minus 2x cubed plus 1. It's a degree 4 polynomial. Has how many x-intercepts? 2, right? Notice that it didn't have 4. It says you can have up at most, right? That doesn't mean you're going to have exactly 4. So here you had 2. And then your function was decreasing all the way to this point, and then it started increasing, so you have one turning point. Okay. What about the second example here, or the second part to this example? You have g of x equals x cubed minus 2x squared minus x plus 1.
3x.
Third degree polynomial. How many x-intercepts? 3. Good. How many turning points? 2. Very good. Okay. What questions do you have? Okay. All right. And I'm going to formalize some information we've already talked about before whenever we talked about graphing functions. We say C is a 0 of multiplicity K if we see x minus c raised to the k in the factorization of our polynomial where k is greater than 0. Now, do you remember a while back when we talked about graphing functions, I told you if you have a linear factor of degree 1, then what it was going to do was cross? This is formalizing that. And then I said if you had a linear factor of degree 2, or it was even, what was it going to do? Touch it and then go back up, right? So it's going to bounce like this. This is just formalizing everything we've already talked about. Okay, does that make sense? All right, so graphically, if x minus c raised to the k is a factor of p, 1, if c is a real 0 of multiplicity k of a polynomial p, the graph of p crosses, I'm going to highlight this, the graph of p crosses through that x-intercept if k is odd. So now if you know k is 1 or 3, like if this k here is 1 or 3 or 5 or 7 or any odd number, your graph is going to cross at that x-intercept. If c is a real 0 of multiplicity k of a polynomial, the graph of p will bounce and stay on the same side of the x-axis if k is even. So if k is 2 or 3, you said? 3 falls into which case? The crossing, right? Or it's odd, good. But here for it to bounce and stay on the same side, k is 2 or 4 or 6 or 8 even, okay? So it's going to bounce, okay? So now we can put everything we've learned together. And as you can tell, you should be extremely confident now because as you're seeing this, you know it's a review of things we've already done, okay? So we're going to sketch the graph of each factored polynomial. So here, to sketch the graph of each factored polynomial, we need to ask ourselves, what is our leading term? And this you might need a refresher on, but we'll do that. Then we need to ask ourselves, what is the end behavior? Our leading term will help us determine that. And then we need to find our zeros and determine the multiplicity. That's what we need to find. If you're given it in factored form, it's very helpful already. So remember, in factored form, we pick up the variables with highest degree from each part. And we pick up a constant out front if it's there. So we have the negative x cubed. Let me not use that one. Negative x cubed, an x, and an x squared. So that will be negative x cubed times x squared. That will give us a negative x to the what power? You're guessing. When you have x to the, a quick reminder, you have x to the m times x to the n, that's x to the m plus n.
Is it x to the 6?
Negative x to, yes, negative x to the 6th. Does that make sense?
Yeah.
Because they all have the same base as x. You have a question? What's your question?
No, I don't know.
Marcus, you have a question? Okay. All right. So when you have the same base, all of them are x, x, and x, that means that you add the exponents. Okay? Now, this has what degree? Even or odd? Even. Good. And there's a negative out front. So what's the end behavior? Downward facing parabola at the end. Good. So it looks like that. Good. I'll switch back to blue. Excellent. And then we find our zeros. Our zeros, we get negative x cubed equals 0, which means x equals 0. X minus 1 equals 0 means x equals 1. Good. And x plus 2 equals 0 means what? X equals negative 2, but the degree is what? Squared. So what's the multiplicity? Very good. Multiplicity 2. And why do we care about the multiplicity? What does that tell us about the graph? It's going to have a bounce. Excellent. Multiplicity 2 means it's going to bounce here. So let's put it all together. So your zeros, you told me, was 0, our x-intercepts. So our zero is another way of saying that these are our x-intercepts. So you have one at 0. You have one where? Negative 2. And where was the other one? 1. Good. Okay. So we know the end behavior looks like this. Then we know the multiplicity of 0 is what? No, the multiplicity of 0. What's the degree of 0? The degree of this, that occurs odd, right? So it has odd multiplicity. We don't need to write it down. We can just say it for the sake of time.
Why didn't we put it up?
Put what up?
The arrows.
The end? Why are the arrows going down? Because there's a negative right here, right? Because there's a negative. That means it faces down. Did that answer your question? Okay. So we know here at negative 2 it's going to do what? Bounce. It's going to bounce and it's staying on the same side. So we know it's going to bounce here. But then what's going to happen at 0? Can't hear you.
It's gonna touch it.
Is it going to bounce or is it going to cross? Why is it going to bounce?
Cause it's supposed to
What's even? How many times does a 0 appear? Remember,
One,
once, right?
we're gonna go through.
So this is a good thing to do. Like, we're making this connection now. So notice that here, we know that it's going to cross at 0 because it doesn't have an even multiplicity. It has odd multiplicity. So in particular, it has multiplicity 3, which is odd, right? Because the degree on x is 3. Are you with me? No? Yes?
Yes.
Okay. All right. So we know our graph is going to cross here. What's the multiplicity of 1? What's the degree of x minus 1? The degree of x minus 1? 1, right? So this is 1. So this has multiplicity 1. This is 3 here. So this has multiplicity 3. Okay? So we know our graph crosses here. And we know our graph is going to come back through and it's going to cross here. Does that make sense? All right. This is what this section is about. I will finish recording it for you and post it, but we're technically done with 6.4. The homework I will move to being due next week, but you should go ahead and start it. Okay?
You told me that you were gonna open 6.2.
Yes. Have a good one. Okay, so the conjugate roots theorem says suppose p of x is a polynomial of degree. What's the degree of this polynomial? Oh, come on. What's the degree of the polynomial? 6.4. For p of x here, what's the degree? What's the degree? Good morning. What's the degree of this polynomial, y'all? Yes, it's in. This is the degree. Good. This is a have a wonderful day. This is a polynomial of degree n. Okay? So, we have a polynomial p of x with only real coefficients. If the complex number a plus bi is a 0 of your polynomial, then so is its conjugate. So is its complex conjugate. If you have a complex number, so let's be clear. P of x is a polynomial with real coefficients. That's important. Now, if the complex number a plus bi is a 0 of this polynomial, then its complex conjugate is also a 0. Okay? So remember, you have your zeros, so you can also talk about linear factors. Right? That's what we talked about at the beginning of the class. So here, let's go through example 4. Given that 3 minus 2i is a 0 of the polynomial f of x equals x to the 4th minus 9x cubed plus 27x squared minus 15x minus 52, let's factor f of x completely. How many factors should this polynomial have? 4. Why?
Because the highest degree
You got it, because the highest degree is 4. So this should have 4 factors. Good. This should have 4 factors, and you can say 4 linear factors, because here we know that the degree is 4. Okay? Now, we know that what is a 0? For this polynomial, we're given what is a 0?
3 minus 2i.
Good. We're given 3 minus 2i is a 0. So our goal here is to factor f of x completely. So we know that 3 minus 2i is a 0. So what can we use to help us factor this? What's the process? Synthetic division. You better believe it. So we write down 3 minus 2i. Then what do we write? What's our row?
1, negative 9, 27, negative 15.
Good. Both of you. Process. Bring down your 1. Multiply, you get? Good. 3 minus 2i. Add, you get what?
Big add.
What?
Negative 9 plus 3. Yeah.
Negative what? What's negative 9 plus 3?
Negative
Good.
6,
Negative 6. What's the rest?
minus 2i.
Minus 2i. And you may need to do an aside where you have to figure out what you get. And if so, do that. So if you need to find out what's next, negative 6 2i times what?
2. I mean 3 minus 2i.
3 minus 2i. Good. So then we multiply first, outer, inner, last. So we get negative 18 plus what? Outer?
No. 12i? No.
Negative 6 times negative 2i is 12i.
Oh, you're right.
Inner?
Negative 6i.
Good. Negative 6i. Marcus joined the party. Now, negative 2i minus 2i.
4i squared.
Good. All of you. 4i squared. Right? That's a squared. So now this is negative 18 plus 12i minus 6i is what?
6i.
6i. Good. Plus 4 times what?
Negative 1.
Negative 1. Good. So then you have negative 18 plus 6i minus 4. What is that?
Negative 22 plus 6i.
Plus 6i. So that's what we get. So negative 22 plus 6i. Add, what do we get?
5 plus 6i.
5 plus 6i. Good. You get 5 plus 6i. So then, excuse me, 5 plus 6i times what?
3 minus 2.
Good. Go ahead and walk me through it.
First out in the last.
Yep.
5. Wait, 15. Minus 10i. Plus 18i. And then minus 12i squared.
12i squared. Remember, I times I is I squared, so be careful. Good. So now that gives us 15. What's minus 10i plus 18i?
8i.
Good. Plus 8i. Minus what?
12 minus 1.
Good. So you get 15 plus 8i. What's the rest?
Plus 12.
Plus 12. What do you get?
27. Yeah, 27 plus 8i.
So you get 27 plus 8i. Add. What do you get?
8. Right? 8 plus 8i.
Say what? What's 27 minus 15? 12 plus 8i. Good. So here you have negative 15 plus 27. So that's the same thing as 27 minus 15. So that gives you 12 plus 8i. And so then we have to check. Now, we're told that 3 minus 2i is a 0, so we really expect this to be what?
0. Right, oh,
What do we expect this to be?
52.
We expect it to be 52, so let's just confirm it. So let's just confirm it. You have 12 plus 8i times 3 minus 2i. So that gives us 36 minus 24i plus 24i minus 16i squared. 24i's cancel out. That gives us 36 minus 16 times negative 1, which is 36 plus 16, which is what? 52, as you expected. So we put 52 here, and we add, and our remainder is what? 0, which is what you expected. So that's just confirmation. Now, what the conjugate roots theorem above tells us is it says that if 3 minus 2i is a 0, its complex conjugate is also a 0. What's the complex conjugate of 3 minus 2i?
Negative 3 plus 2i? No?
No.
3 plus 2i?
3 plus 2i. Remember, your a part doesn't change. The sign in the middle changes. So if you have 3 minus 2i, your complex conjugate is 3 plus 2i. Does that make sense?
Yeah.
So we have 3 plus 2i. Good morning. And so now, what goes as our top row?
1, negative 2, 5.
You said negative 6?
Yeah.
Does everyone agree?
Are we doing the same?
Oh, do we add the eyes? Like the.
That's my question. What do we put in this
Do
row?
we add the eyes minus 2i?
Minus 2i?
Yeah.
Classmates agree with you.
Plus 6i. Plus 8i.
And why do we take everything there? Because they give us the coefficients of a what degree polynomial?
3rd degree.
3rd degree. Good. So what we got from here, can I erase the scratch work?
Mm-hmm.
Okay. So what we get from this first one is that x minus 3 minus 2i is a factor because 3 minus 2i is a 0. That's what this gives us. So far, we have one factor. We expect to find how many more?
3.
Very good. So now let's go through and do this. So let's synthetically divide. Bring down your 1. Multiply, you get 3 plus 2i. Add, what do you get? Negative 3. They're turning out a little bit nicer here. So negative 3 times 3 plus 2i. Go ahead. Do you need me to write it?
No.
Okay. So what's negative 3 times 3 plus 2i? You have to multiply. So you asked, do you have to multiply negative 3 times 3? Yes. But you also have to multiply what by negative 3?
Negative 3 times 2i.
Yes. You have to multiply negative 3 times each.
Negative 9 minus 6i.
Good. Now what?
It'll be negative 4.
Negative 4. Good. Continue.
Negative 12 minus 6i. Like, no, 8i.
Good. Minus 8i. Add, you get what?
0.
0. So it confirms what the conjugate roots theorem tells us. It tells us if you have a complex number is a 0, then its conjugate is also a 0. And we know it's a 0 because our remainder is 0. So what is the corresponding factor?
3x. Oh, sorry. X plus x. X minus the parentheses 3 plus 2i.
Good.
Plus parentheses.
Good. So now we have 2 factors. How many more do you expect? 1, you said?
2 more.
2 more.
You could have.
Because you got from a degree 4 to a degree 3, and now you expect 2 more. So these are the coefficients of what degree polynomial?
2nd degree.
2nd degree. So what can you do?
You can factor.
You can factor it. So we write x squared minus 3x minus 4 equals 0, because your goal is to factor, or you can use a quadratic formula, whatever makes you happy. So you can factor this as x, and x what goes where?
On both sides. What?
Yes, you want two numbers that multiply to give you,
Negative 4.
but add to give you.
Negative 3.
So
Negative 4, positive 4.
negative 4, positive 1. That product equals 0, which means what are your x values?
X equals 4. X equals negative 4.
But did we need to find that at all?
No.
Did we need to find the zeros?
We didn't need to find the 0.
We didn't need to find the zeros here because the problem tells us to do what? Factor, right? So really, you have, this is a factor, and these two are factors. So you're able to factor f of x as the following. F of x is equal to x minus, and if you want to distribute this negative at this point, you can, right? So you can have x minus, I'll write it as we have it above and then simplify it. X minus the quantity 3 plus 2i times x minus 4 times what? Times what? Good, times x plus 1, right? So that's how we factor f of x completely. And you can rewrite this as x minus, you can distribute your negative, times x minus 3 minus 2i times x minus 4 times x plus 1. And that's it. That's it. That's how you factor f of x completely. Okay? So we went over some problems a few sections ago, maybe about 3 or 4 sections ago, where you had to construct a polynomial of a specific degree given some information, given some zeros, and given an extra condition. And remember, I told you that's a good problem for your third exam. But I did not put that on your third exam. So you can expect to see something like that where?
On your final?
On your final exam. This is another problem like that. The conjugate roots theorem, one.
Maybe.
This following one. They be what?
Maybe confusing.
But not anymore, right? We're going to strive to understand. And if you get confused, you're going to ask for clarity so you won't be confused anymore.
Sorry.
Good?
Yeah.
Okay. We want to construct a 4th degree real coefficient polynomial function f with zeros of 2, negative 5, 1 plus I, such that f of 1 equals 12. Where do we start? Where do we start? F of 1 equals 12, we know that. So we can write f of 1 equals 12. We know.
And you have 3 zeros.
So what do those zeros mean?
Those mean that you can write linear factor.
Oh, that thing we talked about at the beginning of class came back again. There's a reason why we reviewed that at the beginning of class. If you have a 0, you also have a linear what? Factor. What you just learned about the complex tells you if you have a complex number, you also know, if you have a complex number that is a 0, you also know what is a 0? It's conjugate. So I gave you 3 zeros, but really how many do you have? You got 4. Okay? So our zeros are 2, negative 5, continue.
1 plus I, 1 minus I.
And 1 minus I because of the conjugate roots theorem. Okay? So now, as you said, you have your zeros. You said you also have what factors? Linear factors. So tell me what your linear factors are.
X minus 2.
Hold on. Our linear factors are, go ahead.
X minus 2.
Mm-hmm.
X plus 5. How would I do that?
Yes, you do. You just write it standard before you try to simplify it.
Is it X minus 1
X minus what?
oh,
Yes.
1 plus 5.
Good. Close parentheses, close parentheses. Good. Then what else?
Then X minus open parentheses
Mm-hmm.
1 minus 5.
Good. You got it. So we know whatever f of x is, it's going to be that. We're going to have a times those linear factors. And we know we have a times that because that's just generally for a polynomial, for a general polynomial. So the thing that's missing is we do not know what a is, right? But that's okay. We can figure out a, because to find a, we use the fact that we know f of 1 is equal to what? 12. So on one hand, we know 12 is equal to f of 1. Whenever you have f of 1, that means x is what? 1. Good. So this is now a times. We're going to substitute in 1 for x. 1 minus 2 times 1 plus 5 times, be careful with your parentheses here, 1 minus parentheses 1 plus I times 1 minus parentheses 1 minus I, and close it up. Are we all right so far? You need to take a minute, or you good? Take a minute. Questions? What questions do you have? So now, we simplify. We can really just zoom in on this portion. Since we have an equality, right? We can just choose to say this equals this. Yes? Okay. So 12 equals a times 1 minus 2 is what? Good. Negative 1. Times what? Come on, talk loud. 6. Good. Here we have to be careful, right? Because this is now 1. Distribute the negative 1 to get 1 minus 1. What's the rest? Minus I. Good. And then what's the other factor become?
1 minus 1 plus I.
Good. So this means 12 is equal to a. What's negative 1 times 6? Good. So times negative 6. Notice I put that in parentheses so it doesn't look like we're subtracting. What's 1 minus 1 minus I? Negative I. Good. What's 1 minus 1 plus I? I. Good. So, what's negative I times I? Good. Negative I squared, right? And we know I squared is equal to what? Negative 1. So negative I squared is what? 1. Very good. So you have 12 equals a times negative 6 times 1. Negative 6 times 1 is? So on the right-hand side, we really have what? Good. Negative 6a. And then we divide both sides by? Good. To get what? Good. To get negative 2. So A equals -2. And all of that to say we found out what A is, which means we now know what? What do we now know?
What's your leading coefficient? Is that what it is?
Yeah.
Leading coefficient?
You know what your leading coefficient A is. Good. So then you just go back and you put that there. So we know f of x, therefore, f of x is equal to -2 times x minus 2. We're using this here. And we have times x minus 2 times x plus 5. I'm going to go ahead and distribute this negative here. So you're going to see times x minus 1 minus I times x minus 1 plus I. And that's your final answer. That's your polynomial of degree 4. What questions do you have? What questions do you have? Okay, so that's everything there. That's from 6-4. Okay, so notice that it's really